Hey guys, video 2 for box and whisker plots. We're going to start off by answering some questions given a graph. The graph says that for questions 1 through 6, and we're just going to answer the first 4 today though, refer to the box and whisker graph below, which shows the test results of a math class. And it shows the test scores as a percentage for 6th period. And our very first question says, what was the highest score on the test? Well, if I'm looking here, I have 5 pieces of data that I can see, 5 numbers I can see, and the highest point on our test would be our upper extreme. Let me do that. Our upper extreme, which would be 102. So 102 was the highest score on our test. Question 2 says, what percent of the class scored above a 72? What percent of the class scored above a 72? Now, if you think about what we've talked in the past before with this about quartiles, and you think about the word quarter or quartet, the quad, that stands for 4. If you notice that our data is split up into 4 segments. We have a segment from there to there, and then one from there to there, and then one from there to there, and there to there. Each one of those segments represents 25, like a quarter percent of our data. And that's true for all box and whisker plots. Between each line, between each dot, is 25% of our data. So it says what percent of the class scored above a 72. Well, if I find that 72, it's right here. What scored above it? Well, if you guys look at it, there are 3 sections above a 72. So how many percent of that is that? That would be 75% of the class scored above a 72 because there are those 3 sections, 3 segments above 72. It said, what was the median score on the test for number 3? Well, the median would be the middle line in our box, which would be 88. And then it says, what percent of the class scored between 88 and 96? So if I get rid of that color right there, 88 and 96 would be between those 2 lines right there, those 2 dots, which is only one section, which would be 25%. So the main thing I want you to take away from there is that each segment of a box and whisker plot is 25% of the graph. If I zoom in real quick, and if I make one real quick using dots, for that graph right there, there's 25% of our data there, 25% of our data there, 25% of our data there, and 25% of our data right there. Okay? All right, let's go down and do one more example of a box and whisker plot. It says use the data below to make a box and whisker plot. And if you notice up here in the right-hand corner, I have the 5 things we need to create a box and whisker plot. The first one of those is our median. So I find my middle number. And I messed it up there. 35, 35. I'm supposed to have 237. Sorry guys, when I order this, I forgot 37. So that should have been there from the beginning. There, and 38. Because if you guys notice, I have 137 right there, and 137 way over there. That's probably why I didn't see it for. So my median would be 38. Zoom out over here. My median would be 38. My lower quartile is the middle of my lower half, which would be 35. My lower quartile. My upper quartile is the middle of my upper half, which is 46. And my extremes are simply my smallest and biggest number. So my smallest number is 33, and my biggest number is 49. So step 1 is to find those data points. Once you have those data points, you would then graph them above the number line that I have down there. So I need a point at 38, a point at 35, a point at 46, a point at 33, and a point at 49. And now remember, the outside dots will create your whiskers. So I have a whisker there, and make that a little bit thinner. I have a whisker there, and a whisker there. Then I'll draw a box with these two. And then I'll have a line going straight down the middle of that one right there. And that is the box and whisker one for that. Now I'll change the color so you guys can see a little bit better. So there is the box and whisker for that example number 1. Okay, we'll scroll down a little bit to way down here, where we have to answer some more questions. So for example 2 there, it says use the box and whisker plot of inches flown by 2 different paper airplanes. And the first question, number 2, says, which paper airplane has a greater median flight length? Well, the median is the middle number, so if I find the A, the median of A is there, the median of B is there, which one's greater? Well, A is farther to the right. It would be somewhere around 190, where the median B would be about 185. So since 90 is greater, paper or airplane A has the greater median flight length. It says which one has a greater interquartile range. So which one is asking then has the bigger box? Is that A or is that B? That would be pretty easy to see, B. And then 4 says which one's more predictable? Predictability, we're just looking at the box. We're not concerned with the whiskers. And the more compact the data is, the more predictable it is. And here, since box A is smaller, it is more predictable. So A is the more predictable of those two. All right, for example, number 2 down here, which one has the greater median? Let's look at the middle numbers. There's one there, one there. Which one's farther to the right? Which one's the bigger number? Well, that'd be apartment A, because I guess I didn't read that. We're comparing the cost of 2 rental apartments now. It says which one has a greater interquartile range? Well, we're looking at the size of the box. Which one has a bigger box? That would also be A. Which one's more predictable? Now, if you look at this one right here has a really long whisker. That does not matter. When we're talking about predictability, we're simply just looking at the box, and that would be box B, or box and whisker plot B. Why is that more predictable? Why does that whisker not matter? Well, that whisker could simply be one number that's an outlier. That outlier could stretch that one all the way to the end. If you think about maybe the data for city B's apartments could be like 425, 450, 475, 480, 475, 380, 390, 400, 475, 480, 475, and then 625. And because of just that one number, it caused that whisker to go all the way out there. That outlier would cause that to go all the way out there. Can we still predict the cost of an apartment in City B pretty well? Yeah, that one outlier is not going to affect how predictable it is. So we're only looking at the box. So that's why B is more predictable, because the block size is smaller. We do